Okay, time for your first distance math lesson. But if you remember, before we left, we were talking about the Pythagorean Theorem. So this might seem like a bit of a backpedal for some of you, but I need to make sure everyone's on the same page. And we're gonna sort of remind you of some of the basics. We did watch that fascinating math documentary about the Pythagorean Theorem, but I'm going to begin from the beginning. The Pythagorean Theorem is a system for figuring out sides in a triangle, basically. If you know two of the sides, you can figure out the third. Most of the time, we're interested in figuring out the longest side. I'll talk to you later about how to figure out one of the shorter sides. It only works when you have a right angle triangle, though. So this is very important. It's for specific types of triangles. However, any line you could make with horizontal and vertical vectors into a right angle triangle. So right angle triangles are very commonplace and quite important. So it's good that we have this law that applies just to right angle triangles. We're also going to use the Pythagorean theorem backwards to figure out if a triangle is right angle triangles, because not only does it only work for right angle triangles, you can also use that to figure out, well, if the law does work, the Pythagorean theorem does work, then I know that this is a right angle triangle. That would be if you knew all three sides, you could check if it works, right? So you can work that way, but we'll get practice with all these sorts of types of questions. So the main equation for the Pythagorean theorem is a squared plus b squared equals c squared. And what that means is that the length of each side is a, b, and c. And the two shorter sides squared and totaled up equal the larger side squared. So I'm going to remind you what we mean by squaring something. Squaring is just taking something to the exponent 2 is squaring something. Why do we say that? Is because, the area of this square, for example, that b square is b times b. Because it's a square, the sides are all equal. So one side was on the edge of the triangle, and the other side is the same length because it's a square. So b times itself, we can represent visually as a square. So the area of this b square plus the area of that smaller square below should be equal to the area of that c square, that diagonal square on the side. So that's helpful. It doesn't tell us exactly what we want to know. It doesn't tell us the length of that side. It tells us the area of the square, right? I can figure out how big the c square is, but I haven't figured out the length of the side. I only can do this if I know a and b, because I can figure out the square of a, I can figure out the square of b, and then I know what the square of c is. It's those two things added together. But if I know the square's area, how do I figure out one side, which is what I'm really interested in? How long was that side of that triangle? And the answer to that is, of course, square rooting. Okay, once you know the square, you can do square root. Square root is just going backwards. It's asking yourself what number times itself is equal to the total that I have here. Okay? So how that would work with practical numbers, this is the most common way to represent the Pythagorean theorem. We've got two sides. The two shorter sides are 3 and 4 units long. So 3 times 3 is, of course, 9. 4 times 4 is, of course, 16. 9 plus 16 is equal to 25. Now, I keep calling them the shorter sides, and talking about the longest side, the proper vocabulary would be to refer to the legs of the triangle. The two shorter sides are both legs of the right angle triangle, and that longest side, the one that we're trying to figure out, our C in the C squared, is called the hypotenuse. But anyway, we have these two squares, 16 and 19. We add them together, we get 25. And that's the area of that C square. Now, it might be obvious that one side of it is 5 if this whole square is 25 units long. But how I'm actually doing that is by doing the square root of 25. I need to know that the square root of 25 is 5. And there's a few different ways to get to that point. One is just to know your squares. So you know 25 is a perfect square. 5 times 5 is 25. So when you get a square root of 25, you just know right away that it's 5. This not exactly is helpful when you're stuck with something like the square root of 576. It would be nice if you just knew that one, but I'm not expecting everyone to be able to do that. So if your a squared and your b squared added up to 576, how would you figure out how long that c side is? Because this 576 is c squared. It's not the information you really are looking for. You're looking for what is just c. What is the length of that side? So I need to square root 576. You can use calculators and the square root button to figure out that this is 576. You could use trial and error. Like you could try a number like 20 times 20 is 400. Okay, I need to try a bigger number than 20. You could use logic to get there. That the number ends in 6, it can't be 22 times 22, for example, because 2 times 2 will end in a 4. So your answer will end in a 4 if you did 22 times 22. So you could try different numbers using both a combination of trial and error and logic. And 4 times 4 ends in a 6. So I'm going to try 24 times 24, and I do end up finding out that that's the correct answer. So what comes out of this is just the idea that in order to figure out these missing sides, not only are you going to need to be able to square stuff, times it by itself, but you're also going to need to be able to square root things. Okay? So the steps that we're going to follow are going to be to square the sides that we're given. Then we're most likely going to add them together if we're missing the large side. And then we're going to have to square root to get back to the number that we're looking for. So what comes out of this is just the idea that you need to be comfortable with both squaring and square roots, because we're going to do a lot of it. So today's assignment is just to practice squares and square roots, and that might be backtracking for some of you, but we're going to start with a little activity where you can try that. There'll be different levels of difficulty that you can select. If you know it really well, try the hardest one. If you want to have fun with it, try it without a calculator, but you can use the calculator for this activity as well. Okay, so the video link should have been posted by now if you're watching this video, and there will also be a link to an exercise that you can complete. That's it for now.